Hello and welcome to the Sunlight and Weather Unit Internalization video. My name is Sean Tamarisk of KIPP, Massachusetts, and Jenna Brutzman of North Carolina also helped put together these master teacher materials. Our big unit question is, how do sunlight and weather affect places? And the anchor phenomena has to do with the effects of weather at two different school playgrounds. Yes, indeed. This is a tale of two playgrounds. It was the best of times at Carver Playground, and it was the worst of times at Woodland Playground. Woodland Playground is hotter than Carver. Woodland floods, and Carver doesn't. Students are confronted with this mystery at the beginning of the unit by the principals of each of these two schools, and their job is to investigate and find the answer to this tale of two playgrounds. So before we begin diving into this unit, please make sure you've completed the following tasks. You should have read over the unit plan, including the standards, content knowledge, and misconceptions sections of it. And please make sure you've printed out the focus tasks and end of unit assessment and are ready to complete those as you go through this video. If you don't already have these, go ahead and pause now and get them together before continuing. All right, as we dive in, let's look at why the material in this unit is important. For many of our kindergartners, this may be their first experience describing and naming different types of weather and thinking about how that impacts what they should wear and whether they should be worried when they hear things like blizzard on the news. Students get to solve a real-world problem as part of this unit as well, using investigation and modeling skills. They learn the skill of graphing and how to interpret graphs, and they learn about how scientists use modeling in the real world to answer questions and solve problems. And students get first-hand experience doing this. Students also get the opportunity to build a mental model of temperature in a playground. So they have to start to understand and be able to predict where the hottest and coldest parts of the playground are, the hottest and coldest materials and surfaces, and what time of day would be the hottest and coldest, thus giving them a more nuanced mental model of outside weather and temperature that they can relate to.
Now, mental models of playgrounds might seem insignificant, but just think about it's this microcosm of what climate scientists themselves do. Instead of modeling a playground and predicting temperature weather patterns, they model the entire Earth's atmosphere and predict temperature patterns in there. So ideally, our kids will be able to make first models of smaller areas and then larger and larger models as they get older. And more importantly, they'll be able to understand the climate science and research that they read about in newspapers as they get older and make informed decisions when it comes to voting and political action.
All right, let's start with the chapter overviews. Big question number one is, what kinds of weather are there and what do they feel like? After introducing the unit problem of the two playgrounds, our first mystery to solve is to figure out whether the weather is different at these two playgrounds and is that what's causing these differences. So students look at and discuss different cards with pictures of different weather and learn the symbols for weather in order to build up their vocabulary and the ability to describe different weather such as cloudy, windy, rainy, and sunny. They read the book, What Is the Weather Like Today?, about a girl who looks out the window every morning to try and determine what she should wear for the weather that day. In this first lesson, students will begin a weather routine that they'll complete at the beginning of class each day, where they'll look out the window and discuss what the weather's like that day, and fill in a square in the graph here, and fill out a square in the graph here depending on what the weather is for that day. By the end, having a fully completed weather bar graph. In the next lesson, students learn how we measure weather. They learn about temperature and the range of temperatures that we might see on a thermometer, from very cold all the way up to very hot. Students will have this as a reference guide in their notebooks and as a slide in the PowerPoint deck for the remainder of the unit. Students learn some common things that happen at these temperatures, such as ice freezing at 32 degrees, fridge being around 40 to 43 degrees, classroom being on average around 70 to 72 degrees, and chocolate melting at around 90 degrees. For this unit, students will have liquid crystal thermometers, which are easy to read thermometers because they highlight with a colored rectangle what temperature the thermometer currently is at. For example, this one's currently at 82 degrees. Note that the Amplify kits come with Celsius thermometers, but I strongly recommend getting Fahrenheit thermometers instead. They're very cheap, and I think for kindergartners, learning Fahrenheit first before learning Celsius will help them contextualize and learn weather better than if they were to learn only Celsius. In the following lesson, students go outside and measure the temperature at their school playground. If there's no playground right at the school, any spot outside will work just fine. The goal is to get students accustomed to using the thermometer and start to think about where interesting temperature differences might be outside. Next, we come back to the problem of Carver Playground and woodland playground and ask ourselves, maybe it's just differences in weather. So students look at a record of the weather at both playgrounds over several weeks and use that information to create a graph of the weather at each playground. Once they count up the columns, they realize that these two playgrounds have had the same number of sunny, cloudy, windy, rainy, and snowy days as each other. So the weather is actually not a factor in the differences between these playgrounds. Next, students begin to investigate the role that sunlight has in affecting temperature. A recurring theme throughout this unit is the use of models, and so students are going to model the sun with heat lamps such as these with thermometers underneath. In this particular case, students will compare the temperature of the thermometer under a heat lamp that's off and a heat lamp that's on to see the effect that the heat lamp has on temperature and, by extension, the effect that sunlight has on temperature to represent night versus daytime. Students then go back outside and take the temperature in spots that are in the sun as well as spots that are in the shade.
So we're going to test spots like this, spots like this, spots like this, spots like this, and spots like this.
And determine that it's usually cooler in the shade than it is in the sun because the sunlight heats surfaces. Students then model this by creating a structure and placing it under a heat lamp with a thermometer underneath and compare that temperature to the temperature of a thermometer with no structure to represent shade versus sunlight. At this point in the unit, students should understand Progress Build 1. Weather can be sunny, cloudy, windy, rainy, or snowy, and it can be different temperatures. When sunlight shines on a surface, the surface gets warmer. And it's usually colder at nighttime than in the daytime because the sun is not out at night. At this point, we'll use Progress Build 1 focus task to assess student understanding of the progress build. Go ahead and take a few minutes to complete this task and then check back here for answers. Go ahead and pause now. Great, here are the completed answers. Go ahead and check your work. And you should have students make an attempt at writing. Given that it's kindergarten, I always give students the option to answer verbally here after they've tried to put their thoughts in writing so that they can demonstrate their understanding verbally even if they're not able to demonstrate their understanding yet in writing, and they can still get full credit. I'll set aside some time to have quick one-on-one conferences so students can explain their thinking in number 4 and number 6. All right, on to big question number 2. Why are some surfaces warmer than others? In the previous progress build, we determined that surfaces are usually warmer in the daytime and cooler at night because the sun is out in the daytime. Now we look at how long objects and surfaces are in the sunlight and how that affects temperature. We do this by setting up lamps that are not shining, that are shining for a short amount of time, and that are shining for a longer amount of time on a surface with a thermometer underneath. Students determine that the longer an object is under the lamp or in the sunlight, the higher the temperature. Next, students read the book Getting Warm in the Sunlight about how animals, such as lizards featured here, sit in sunlight in order to soak up heat, and how by the afternoon the environment actually gets too hot for lizards because the sun has been out all day long. Next, students complete a mini book to summarize some of the things they've learned so far about playgrounds and surface temperatures. Finally, students return to the question of why Carver Playground was not as warm as Woodland Playground in the morning and afternoon, even though the weather was the same. Students notice that Woodland Playground has a black asphalt surface, whereas Carver Playground has a light-colored gravel surface. And the color difference could be causing a temperature difference. Students test this idea by placing dark-colored materials and light-colored materials under heat lamps with a thermometer and test which gets warmer, the dark-colored materials. Next, students go back outside to the school playground or another outside area and test the temperature of surfaces that are darkly colored versus surfaces that are light in color, confirming that indeed the darker colored surfaces absorb more heat. Finally, students read the book Cool People in Hot Places, about different ways that people around the world stay cool when it's really hot. For example, by installing sprinklers in playgrounds or by wearing lighter colored garments that don't get as hot as darker colored garments. By this point in the unit, students should understand Progress Build 2. Temperature increases with time and sunlight. Different surfaces heat differently in sunlight. Darker colored surfaces get warmer in sunlight than light colored surfaces. Students show their understanding by completing the Progress Build 2 focus tasks shown here. Go ahead and take a few minutes to complete the task and then check back here for exemplar responses. Pause now. Great, here are the answers. You should have marked afternoon because the sun has been shining for a longer time, and you should have explained that Woodlands Playground is warm in the afternoon because it has a darker surface on the ground. All right, on to big question number 3. What is severe weather and how does it affect places? Students learn from the principal of Woodland Elementary School that the Woodland playground floods frequently in rainstorms and asks students to help solve this problem. Carver's playground, on the other hand, doesn't flood, even though the weather at the two schools is the same. So what could be causing this flooding? Students confirm that the weather is the same by adding up the number of rainy and cloudy days. Yep, checks out. Then they read more about severe weather. They read the book Tornado about a meteorologist named Lynn who studies severe weather and makes forecasts for tornado predictions to try and keep people safe. The book also talks about different ways that people stay safe during tornadoes. Next, students discuss what constitutes severe weather exactly. This is important because many kids will assume that a simple rainstorm is severe weather or flooding because they'll see water on the ground. But that actually is not what we mean by severe weather. We show students slides and pictures of severe weather, such as knocking down trees, and non-severe weather, such as a simple rainstorm. Next, students read the book Handbook of Models to learn more about how scientists use models to investigate real-life phenomena, just like how students are using the heat lamps as models to represent the sunlight and investigate the phenomena of temperature. They use this idea of models to return to the two playgrounds and create a model to test flooding. First, students look at the differences between the two playgrounds to determine what variables or what factors could be causing one playground to flood and the other to not flood. They note that Carver's playground trash cans are covered, whereas Woodland's are not. Carver has a fountain, whereas Woodland does not. Carver has a pale colored ground, whereas Woodland is a dark color. And Carver's has gravel, whereas Woodland has a solid ground. We then have a model to represent each of these, such as a bottle cap to represent trash cans, either covered or uncovered, a bottle cap with water in it to represent a fountain versus no fountain, the bottom of a pale cup versus a dark colored bottom of a cup, and gravel versus a solid material inside a cup. And then we pour water over each of these to represent rain falling and see whether it makes a difference in terms of how much water accumulates. Students determine that the first three factors don't affect how much water is accumulating, but that the fourth factor does. The gravel absorbs the water, so it doesn't accumulate, but the solid material causes water to sit on top and fill the cup really high. Students determine that it's the material of Woodland that is causing the water to not drain properly and to cause flooding. Awesome. So how do we fix this? Students discuss different design ideas, different possible ways this problem could be fixed, such as adding more trash cans, putting the playground on a slight hill, or adding a structure over the playground. We quote unquote test each solution by showing students what would happen if each of these was built and tested. Well, none of them stopped the flooding. We consider additional solutions such as putting gravel in Woodland's playground or putting storm drains in Woodland's playground and discover that both of these solutions will work to stop the flooding. Ta-da! Students wrap up the unit by completing a letter to the principal of Woodland Elementary explaining what they found and how the principal could solve the problem of flooding. Great! At this point, students should understand Progress Build 3. Severe weather is strong and dangerous weather, i.e. tornadoes, flooding, heat waves, that can cause damage. Predicting and preparing for it can help us stay safe. And Progress Build 3 Focus Task assesses student understanding of this part of the unit. Go ahead and take a few minutes to complete it, and then check back here for answers. Pausing now. Alright, this is what you should have gotten. Rainy weather causes flooding. That was probably severe because it did cause a flood. That the gravel versus solid was the difference in the playgrounds. And then unless the principal changes anything, this will keep happening. All right, on to the end of the unit assessment. The assessment questions are grouped by Progress Build level. Here's a question that assesses Progress Build 1. Take a second to answer it, pausing now. Great, you should have gotten Wednesday as the hottest day. You can tell both from the fact that the sun is shining all day and from the temperature being higher than the other 2 days. Once again, this assesses Progress Build 1, shown here. This question assesses Progress Build 2. Take a second to complete it and then check back here. Great, you should have picked the white shirt because dark surfaces get warmer than pale surfaces. Once again, this assesses Progress Build 2, shown here. Alright, on to a Progress Build 3 question. Here students are asked to circle words that are examples of severe weather and put an X on those that are not severe weather. Once again, take a minute to answer this and then check back here. Alright, hopefully you circled these 3. And once again, this assesses Progress Build 3, shown here. Well, that does it for our unit internalization video. Thank you so much for taking the time to be as prepared as possible for your students. For KIPP teachers and for anyone else, I actually recommend doing these following steps to get fully prepared. Go ahead and look them over and finish them up. Thanks again.